Hi, I'm Braden. I'm CTO at OpenCraft, and I'm going to be talking about how we built LabXchange using OpenEdX. Here's a quick overview of what I'll be talking about today. First, I'll talk about the vision for LabXchange, and then I'll give a quick demo of some of the features of the platform. I'll talk about why we decided to build it on OpenEdX, and then I'll talk about the technical architecture of LabXchange. And then the focus of this talk is going to be looking at the different OpenEdX APIs that we use to implement LabXchange. And this will be a pretty technical talk. After that, I'll quickly look at features that we did not use OpenEdX to build, and then the end result, and talk about how you can start using these APIs yourself in your own projects. So LabXchange. We first heard about LabXchange at OpenCraft in 2018 when we were approached by the Harvard Department of Molecular and Cell Biology about their vision for the platform. And this is an ambitious life sciences education platform created by Harvard and funded by the Amgen Foundation. The goal for LabXchange was to take the best life sciences education content in the world and aggregate it on one platform, and specifically to aggregate it as small learning experiences. So individual videos or individual assessments or individual activities that you can take on their own, more so than course length material like you find on edX. And one of the key requirements for the platform was that it have a very distinct user experience, that it be very visually appealing and have an easy to use UX for users. And there were a ton of other features envisioned for the platform, and I'll show you that as I give a platform demo now and throughout this talk. So today you can go to www.labexchange.org and you can see the platform. I'll give a quick run through of a few of the features now. You can go to the library and you can see that there are over 9,000 English language assets on the platform and even more in other languages. If I search for a keyword like vaccine, I can see content related just to that topic. And then there are different filters that I can use to narrow down my search for content. In this case, I'll filter on the immunology subject area. And you can see that there are 149 results related to vaccines and immunology. This one is a pathway, which on LabXchange is somewhat akin to a playlist on YouTube. A pathway combines different pieces of content into a linear sequence that students can work through. You can see the first two items in the pathway are just text and images explaining vaccine development. And then the next item students will get to is this assignment. If I go into the assignment, I can see that it contains multiple choice questions. These are the same multiple choice questions used in edX, just styled differently. And you can work through the assignment, but I'm going to jump ahead to the next item in this pathway. This is a video, and again, you can see this video on LabXchange works just like videos in edX. I can jump ahead to the next item in the pathway, and this is a simulation. And these simulations are more interactive activities. Some of them can simulate a lab activity virtually. Others can be all kinds of things. And this one is a drag and drop activity to show that you understand the process of vaccine development. So I drag these items here and put them into order. Every simulation is different. You can see on this one, if I get it wrong, it gives me contextual help explaining my mistake. And then I can go back to the pathway. And one of the other features of LabXchange pathways is that I can clone a pathway. So here, I'm logged into my Braden user account, and this pathway was originally created by LabXchange, but I can click clone, and that will create my own private copy of the pathway. And now you can see I'm editing my copy of the pathway. I can rename it, I can change the metadata, and most importantly, I can change the content in the pathway. So I can move items around, I can delete items, and I can, let's see, delete, delete, delete. And if I edit an item here, I can also add a note. So I can put my personal annotations on items in the pathway, even if those items were originally created by some other provider. Then when I'm happy with my version of the pathway, I can go down. Oh, by the way, you can see there's lots of metadata here, tags and learning outcomes. So I just accept the terms of service and hit save. This will take a few seconds. And then my copy of the pathway will be saved. And with this new pathway, I can just use it for my own learning purposes, or I could assign it to students, or I could make it public and publish it in the library. And then other people can make their own pathways from mine or just use it. So that was a really quick tour of some of the key features of LabXchange, searching the library for content, using pathways, and then creating custom pathways. I'll show other features as we go through this talk. So why did we decide to build LabXchange on OpenEdX? One of the first reasons is that since LabXchange is an aggregation platform where we're pulling content in from different providers, we're going to need some kind of adapter framework to make content from all these different providers appear consistently on the LabXchange platform. And we realized that edX already has an adapter format of sorts, which is XBlocks. XBlocks can be used to display different types of content. So we realized that we don't have to create our own new adapter format. We can just use XBlocks. And there's already a lot of great XBlocks out there. Next, one of the sources that we're pulling content from is edX courses themselves. So building LabXchange on the OpenEdX platform makes it easy to pull in content from edX courses. Then, since we knew LabXchange would be a popular platform with a lot of users, we wanted to make sure that the underlying technical architecture was scalable to handle that kind of load. And we knew OpenEdX meets that criteria. edX.org has millions of learners using it, and OpenEdX has been proven at scale. And then, of course, OpenEdX is open source, and that gives us confidence that some external party is not going to suddenly remove a key piece of the platform that we need in the future, and we can develop with confidence. And then last but not least, LabXchange is part of Harvard, and Harvard was one of the founding members of edX. And OpenCraft has also done a lot of work with different schools at Harvard over the years. So there's a great relationship already between Harvard and edX, between edX and OpenCraft, and between OpenCraft and Harvard. And that great relationship really made it a lot easier to create an ambitious project of this type. That said, there were still some challenges with using OpenEdX in particular for this platform. One of the main ones is that LabXchange is focused on making it really easy to access small pieces of learning content, bite-sized content, if you will. And OpenEdX is built around the concept of courses, where before you can even see the content, you need to register an account on the platform and enroll in the course, which nominally commits you to weeks or months of learning. So that was one difference between OpenEdX and LabXchange. The second is that the OpenEdX platform has fairly limited search features and doesn't support tagging, which, as you saw, was a key requirement for LabXchange in order to make the library work and let users filter through thousands of pieces of content. And then OpenEdX has pretty limited social features. There's pretty much just a discussion forum within each course. But for LabXchange, we wanted a lot more. We wanted a site-wide discussion forum and direct messaging between users and all these other features. So we weren't able to use OpenEdX for that. Okay, really quickly, what is the overall technical architecture that we use to implement LabXchange? Basically, the LabXchange front end is a React single-page application. We use TypeScript instead of JavaScript, but otherwise it's pretty similar to edX micro frontends. The LabXchange backend is a Django application that runs on Python, just like OpenEdX. And we use REST APIs between the front end and the backend, and we use REST APIs between the LabXchange backend and OpenEdX. And we deploy the LabXchange backend on Kubernetes on AWS. And one note here is that the LabXchange frontend and backend are not open source, but all the plugins and integration points with OpenEdX are open source. And we made a lot of contributions to OpenEdX that you'll hear about in this talk as part of the LabXchange project. And those are, of course, all open source. So now we're getting to the heart of this talk, which is the different OpenEdX APIs we use to implement LabXchange. Let's take a look at different LabXchange features, and then I'll tell you the OpenEdX APIs that they're using behind the scenes. Here is the single sign-on process. You'll see when you go to LabXchange and you click Login, you'll be told that LabXchange uses the same user accounts as edX.org, and you actually get sent to edX.org, and you log in using the edX.org login form. Then when you finish logging in, it will take you back to LabXchange, and you can now use the LabXchange platform using your edX.org user account. You can see here, if I go to my profile, I can see my edX.org user profile. And if I log out of LabXchange, it will log me out of edX and out of LabXchange. So how does this work? Well, because LabXchange is a Django application, we can use this great edX auth backends package, which you can find on GitHub. And you just have to set the 3 settings that I showed on the slide here and add that package to your Django project. And then on the edX side, you have to configure your backend as a new OAuth 2 application. And then it will pretty much just work. And edX auth backends is great. It provides everything that you need out of the box, and that makes this quite easy. I saw recently on the OpenEdX forums that someone made a similar package for Ruby. So if you're more of a Ruby person, you can check that out too. Next, as you can see, LabXchange has user profile pages, and they look similar to the user profile pages on edX. And we sync user details between the 2 platforms. So your username, email address, full name, and the text of your bio on your profile are all synced in 2 ways. So you can edit them on either site, and they'll update on the other one. And this just uses the standard OpenEdX user account and user profile APIs, which you can see in the bottom left of this slide. Now let's look at the workflow for creating content on LabXchange. Here you can see I'm on the LabXchange homepage. And if I go to my dashboard, I can go down here and click this button to create content. I'll choose to create an assessment, and I can choose to create a single select assessment. Then this page is LabXchange's version of Studio. So this lets me create new content directly from the LabXchange dashboard. In this case, I'm creating a multiple choice question, which is exactly the same problem XBlock at Studio uses when you create a multiple choice question in Studio. So first, I just set some metadata like the title and a description of the problem. Then I ask a question, and then down here, I choose the available options for this multiple choice problem. You can see that this uses a visual editor for creating problems. So you don't type out Markdown or XML, you just use this UI to create the problem you have in mind. I'll just add a third option. And then with this visual editor, you click on this check mark here to indicate which is the correct answer. And then down on the page here, you can set metadata. For example, I could tag this new problem with a subject area, or I could add freeform tags, or a few other things. But I'm just going to leave that for now and agree to the terms of service and then publish this. Behind the scenes, this is using the new Content Libraries v2 API and creating new content in Blockstore. When I click publish there, it actually creates a new content library, then creates a new XBlock in the library, sets its OLX, and then publishes it to save the draft. And then here you can see the end result. It's now an XBlock published on LabXchange. I can go in and as a user or a learner, I can choose an answer, submit, and you can see that if I choose the right answer, I get a score of 1, and if I choose the wrong answer, I get 0. So how does that work? Well, here you can see this is a list of all the API endpoints in the new Content Libraries v2 API. And as I mentioned, for that flow that I just showed you, we're using the ones I bolded on this slide. So first we create a library, then we add an XBlock to that library, in this case, a Kappa problem XBlock. Then the visual editor, it actually runs in the front end and it generates XML. So we use the set library block OLX to set the OLX for the new XBlock. And then we use commit library changes to publish it and save those changes. And if you want to play around with this API or read more about it, you can find it in the edX platform source code at the path shown at the bottom of the screen. So as I mentioned, the editor, the visual editor for problems, it generates OLX. And the new Content Libraries v2 feature that we built and are using for LabXchange, it has APIs to get and set the OLX XML of individual XBlocks. So here you can see this is the OLX for that problem I just showed. And we use that API endpoint to save it to that XBlock. Then when we display XBlocks to learners and let them interact with it, we use the new XBlock runtime, which we developed that is a new XBlock runtime for content in Blockstore and in Content Libraries v2. And these are some of the API endpoints from that we use in LabXchange. You can see render block view, get XBlock metadata, get XBlock handler URL, and call XBlock handler. So if you're familiar with XBlocks, you'll see that those basically cover all of the APIs that you need to display and interact with XBlocks on the platform. And you can check out this API in the path shown at the bottom of the screen. Now, as you can see, we let any user on LabXchange go and create new content. And that means we have to be worried about malicious content and putting in JavaScript or something that can capture user sessions or call APIs on behalf of users. And so to avoid that, we put all content that we display in an iframe, and we serve that iframe from a essentially a random domain name. And we at first tried using all the sandboxing features that web APIs have for iframes, but we found that that blocked some things like YouTube from working correctly. So instead, we use this approach where we use an unrestricted iframe, but we serve it from a random domain name. And the result is that the code in the iframe can do pretty much whatever it wants, but it cannot access the edX or the LabXchange session. And the only APIs it can call from LabXchange or edX are the XBlock handler APIs that we expose to it. So we've been very happy with this sandboxing approach, and it lets us accept any type of user-created content on the platform in a secure way. Then one of the key features for LabXchange, as I mentioned, was that we want to remove as many barriers as possible for users coming on and interacting with content. And in particular, we don't want users to have to register before they can start testing content out. So if you go on the platform, you'll see that you don't need to register before you can interact with most content. And we get that pretty much for free with the Content Libraries v2 APIs and the new XBlock runtime APIs that I just showed. And because we built those from the beginning with this LabXchange and anonymous access use case in mind. So if you build something with those APIs, you can support anonymous users, that is users who don't need to register, and you won't have to do anything else. It will just work out of the box. Next, when we allow users to import content from edX courses, we use the OLX export API. Now, prior to this point, there was no way to get the OLX of XBlocks on the platform other than exporting a course tarball and producing a huge file with the XML of an entire course. So we created this new plugin for OpenEdX. It provides one new endpoint, which is a get endpoint, and you just pass in the ID of any XBlock in a course, and it will spit out the XML for that XBlock, as well as a list of any image files or PDFs or other static files referenced by that XBlock. So this is an easy way to export content out of ModuleStore and import it into Blockstore, or otherwise access specific XBlocks in ModuleStore courses. Next, to implement the pathways feature that I showed earlier, we introduced a new plugin that defines pathways as a learning context. And this is a new concept in the platform, and it basically just means that the LMS is aware of these pathways, and that if an XBlock appears in a pathway, it has a unique state and a unique grade for that pathway compared to other places it might appear on the LabXchange platform. So that said, most of the implementation for pathways is in the LabXchange backend and frontend. So this pathway plugin is not super useful on its own, but if you're curious about how we implemented it, you can take a look, and there is some interesting code that you can find at the GitHub URL there at the bottom of this slide. Then we made a bunch of custom XBlocks for LabXchange. I'll have to go through these fairly quickly, but there's an assignment XBlock, which lets you combine a bunch of problems together into a cohesive assignment. There's a case study XBlock, document XBlock, image XBlock, simulation XBlock, which I showed earlier, narrative XBlock, and an audio XBlock, which lets you see, lets you hear rather things like podcasts. Then quickly, some things that we were not able to build using OpenEdX. The discussion forum on LabXchange is powered by Discourse instead of OpenEdX. The visual problem editor was originally developed by Raccoon Gang, and we are planning to contribute it to OpenEdX, and we've been talking with edX about that. So hopefully we can see something like this in Studio one day. But for now, this is unique to LabXchange. And then the search and tagging features, we built those using Elasticsearch, and the metadata that they use is just stored separately in the LabXchange backend. Then LabXchange also has a classrooms feature. So classrooms let you get a group of learners together, and then you can assign them content. And once they work through the content, you can see the grades that they got on the content you assign them. And classrooms also provide a discussion forum that's private to that group, so learners can talk with each other and with the instructor. And most of the implementation for this was done on the LabXchange side, but of course, the way that the content works uses OpenEdX, and the way that the discussions work uses Discourse as the backend. And to display the progress reports in classrooms, because the LMS isn't aware of classrooms, and there's no way to say that we want to intercept only LabXchange relevant grades, we use a bit of a hack, and we have to monitor for the Kappa problem submit event, and we just intercept that and use that to store the grades and cache the grades on the LabXchange side. And that way we can do very performant grade reports for classrooms and let instructors see how their learners are doing. Then really quickly, LabXchange has some other features. It has in-browser notifications that pop up when something happens, like a learner requests to join your class. It has mentoring, where mentors can assign content to mentees. And it has internationalization. This is a relatively new feature. And now you can access LabXchange in all the languages shown here. So LabXchange launched on January 22nd, 2020. And as you know, the world was soon thrown into the grips of a global pandemic that caused a surge in interest in online learning. LabXchange was one of the platforms that saw a lot of that interest, and we're thrilled to say that in the first year, there were 6.2 million unique learners who used the LabXchange platform. And as you can see, there are also thousands of resources on LabXchange and thousands of teachers using the platform. So we're really thrilled with the success of the platform and how it's working. Then the last thing really quickly, if you want to get started playing with some of the APIs that I talked about today or with Blockstore in general, a great place to start is the new content libraries front end for Studio. And the URL for it is shown on the screen here. If you go to GitHub and check that out, the README has instructions for how you can set it up on your dev stack, and then you can start playing with some of these APIs yourself. All right, now I'll take questions.